We now want to think about hair, because hair is an appendage of the dermis. And hair is out of hair follicles. So let's draw a picture of this. So again, we've got the surface of the skin there. This is the surface of the epidermis. And the hair follicles go deep down into the dermis, and there's a wider part at the bottom there, like that. And as always, we have the epidermis on top and the area of the dermis below. And as we've noted already when we looked at the epidermis, epidermal keratinocytes line all of the inside of the hair follicle, all the way down to the base. And this is very important if there's partial thickness injuries, if the top part of the skin is lost. Because this means there can be epidermal regeneration from the keratinocytes within the lower parts of the dermis in preserved deep dermal structures. So here we have the hair follicle. And the hair is inside the hair follicle. So here we have the hair in here. Now there's actually a projection up the way like that. That's called the hair papillae. The hair papillae inside the hair. And the hair is going to grow inside here like this. Now what we actually have here in this bottom area is the germinative layer of the hair. So there's ongoing mitosis here with epidermal type cells. And these cells are pushed away from the germinative layer up the way, and they die and they become compacted cells. So as the hair grows, it's compacted cells, compacted keratin producing cells. And the hair grows up the hair follicle, forming a shaft like this, coming out onto the surface. So all this is the hair. This is the hair shaft. This bottom part at the bottom is called the bulb. The wider part at the bottom is called the hair bulb. Then this is the shaft. Compacted, dead, keratin yielding cells held together by some protein extracellular matrix. So that's the hair. And the colour of the hair is also determined by this germinative layer, because in this germinative layer there are cells which will add pigment to the hair. So there's pigment producing cells here that give the hair its colour. And if you have got grey hair when you get older, that's because there's a lack of pigment. There's less pigment present in the hair. Now we mentioned that there's a dermal papilla here. This is important because we have a arterial branch coming along here, and there's going to be a branch, a small arteriole going into that, taking nutrients in. And then there's going to be some capillaries in here, small area of capillaries, and then the venule will drain out the way, connecting up to a venous vessel. So blood containing oxygen and nutrients is going to go into this dermal papillae, this area in here, and that's going to nourish the tissue fluids in that area, meaning that the germinative layer of the hair is going to receive the oxygen and the nutrients that it requires. Now, also associated with the hair follicles, there are other structures fairly near the surface that open onto the hair follicle, and these are called sebaceous glands. And the sebaceous glands a glandula. They produce a product. So round about the edge of the sebaceous gland here, there's going to be cells. And these cells are going to excrete sebum into the gland. Let's draw sebum as a green colour today. It's not really, but it is today. So there's the sebum being produced by the sebum producing cells in the sebaceous gland. And the sebum is an oily material. It's waxy and it gives the skin waterproofing. It contains triglycerides and cholesterol, and it contains some protein and also some mineral salts as well. And it makes the surface of the skin oily and supple, and it stops it from drying out, and it improves the waterproofing of the skin as well. And if you just rub your finger between your nose and your face there, can you feel that sort of oily stuff there? That's sebum. And it's good because it's keeping the surface of the skin moist. And also it has some antibacterial properties. So paradoxically, if you wash a lot, and you wash a lot of the sebum away from the surface of your skin, that can actually remove some of the antibacterial properties that sebum naturally has. So sebum produced by sebaceous glands. And in nearly all parts of the body, the sebaceous glands are opening into a hair follicle. And the sebum travels up the hair follicle and onto the surface of the skin. That is the situation in most parts of the body. The hair follicle is the medium for taking the sebum from the sebaceous gland at the neck of the hair follicle out onto the surface of the body. Now also in this unit with hairs, hairs also have what's called a hair erector muscle, or an erector pili, a hair erector muscle. I guess erector pili is kind of Latin, some people still use that term. But what it is, the hair erector muscle is a muscle that's connected to the hair follicle. So it's connected here, and it connects up onto some adjacent epidermis as well, connects up there. And there's a muscle here, a small muscle. So this muscle is called the hair erector muscle, or the erector pili. Now what's it doing here? Well, when this muscle contracts, what it does is it pulls the bottom of the hair follicle that way, and that means the hair is going to move up that way. So when that contracts, that's going to move over and the hair is going to become more erect. It's exactly what it says. It's a hair erector muscle. It makes the hair stand erect. So what's the purpose of that? Well, the idea is that if you have lots of hairs standing erect on the surface, what you're actually doing is trapping a layer of air next to the surface of the skin. So this would be trapped air next to the surface of the skin. And air is a particularly good insulator of heat. It keeps the heat in. So the hair erector muscles are going to contract when the person's too cold. And as the hair erector muscle contracts, it's going to pull that part of the dermis, or that part of the epidermis, down, making an indentation in that area of the epidermis where it pulls down. And in English we call this goose flesh or goose pimples. So when you've got goose pimples, it's because you're cold. But the idea is that it increases the boundary layer of air. And it would only be effective if you were a particularly hairy person, but that's what happens. So, bit to the hair follicle really. We've got the hair follicle, blood supply to the hair pili, the growing hair bulb, the hair shaft coming out of the hair follicle, the associated sebaceous gland, and the associated hair erector muscle. But there's another component as well. Do you remember when we talked about sensation? Well, you can actually become aware of touch if someone just brushes the surface of the hairs without actually touching the surface of the epidermis. So to become aware of touch, you don't actually need your skin to be touched, just the surface of the hair to be flicked. And this is particularly true with eyelashes, and it's particularly true with mice and rats who have whiskers that are very sensitive, that they can detect their way through tunnels in the dark. Well, we also have this as humans, because there's an arrangement of nerve fibres around the hair follicle called the hair root plexus. So around about the nerve follicle, with a fibre of a sensory nerve going off towards the central nervous system, there's a plexus of nerves, a collection of nerves around about the follicle. And these are very sensitive to light touch. So if the hair is flicked on the surface, that's going to make the hair flick inside. And just a very light touch on the hair on the surface will actually stimulate this, because you've kind of got a leverage effect. You've got that whole hair as a leverage effect. So if someone flicks the hair on top here, like that, that's going to move the hair deeper down in the follicle. That's going to slightly move the follicle, and that's going to be detected by this sensory hair root plexus. And here we have the dendrite of the sensory neuron taking that information off towards the central nervous system, where we will experience it as sensation.